Zach.
The one who mentioned it at
Zach.
passage that we had to raise for air programs.
You were doing this?
They were the big ones, I think they're called.
Guys. I'm not playing. I'm not playing. I'm not playing. Please. Please.
Mr. Lee, what was the name of the video you posted?
Optimization? Okay, so today we're going to talk about optimization.
We basically
No.
So let me see, how can I help her?
You're gonna have to teach me. What? Who's this?
What was that?
Jared, you're gonna have to teach me.
Teach you what?
Got inspired.
Yeah, Inspire. I know how to use it for stats. No.
You wanted to shift one, right? Should we write this stuff down?
Yes, please. I'll tell you in a second. Let me send.
Optimize problem. Optimization.
I'm trying to stress over like, wait, is that how you roll or what do you I'm just like, use it if other times have passed.
Okay, so we're going to talk about optimization problem. And optimization problem has things like this. So optimization problem is basically draw a picture that you have assigned variables. And then we're going to talk about other things. So find what you're trying to optimize. I'm sorry about language. My language sucks. You're trying to draw a picture that have assigned value. So very mainly you want to draw a picture that have assigned value. Find you try to optimize. So you could be optimized. For example, if I have a water bottle here, right? If I have a water bottle, what can I optimize in this situation?
Volume.
I can optimize the volume. What else?
Surface area.
Surface area. What else? Yeah, but that's not what it won't be. It won't be optimized with the goal. What are you trying to, if I'm build this water bottle? What are you trying to do?
Alright.
Strength of volume.
No, not the shape of the ball.
If I'm a company CEO, I'm gonna present this. What am I trying to do?
Display the product.
Oh, cheap.
I'm trying to make money. Obviously, I'm trying to make money, so I have to what? Besides maximize volume, what else I can do? What is it?
Minimize the surface area without losing value.
Right. Yes, true. Without losing value, so minimize the material use, right? Because surface area is going to be material use. So if I give you some type of material use, I want to minimize this situation. So those are things that you should try to do. Is you try to think about optimize. There's a lot of commercial use. Those are engineers, they are thinking about this all the time. They're not just going to build a plan that costs $100 million. They want to build a plane that can do just as well at $50 million and then still do just as well as $100 million plane. So those are things you're trying to optimize every single time. So then your goal is you think about all the situations. So you draw a picture that have assigned variables, find what you're trying to optimize, which is called primary equation, and also find constraint. So for example, constraint can happen of this bottle. It could be like this. I only want to use 500 grams of plastic. And I don't want to use any more than 500 grams plastic. And that's my goal, to build in the best bottle out of 500 grams. That's a constraint. My constraint is a 500 grams of plastic. It's possible to build your best bottle of this. And I'm trying to minimize the cost, trying to maximize the profit, trying to do a lot of things. All to do is optimizations. Then you kind of think about find what you're trying to optimize, find constraint. The constraint is trying to reduce your variable. Number 4 step is insert the constraint in its primary. We actually did that with the cone problem. The cone problem, remember, has a ratio of R and H. And we tried to solve for R or H to reduce the variables. Because we don't want to take a derivative with 2 different variables. We don't want to deal with that. So we deal with similar question in the past. This is not the first time we've seen this, and that's why we deal when related rate, when we deal optimization, you should feel a little bit more comfortable than before. Take a derivative and set it equal to 0. Why do we do that? We're trying to find the maximum and minimum. When you take a derivative, set it equal to 0. Now you got to answer the question. Obviously, you got to answer the question that is, that's 0 or not. You got to answer the question whether you're trying to, for example, they want to find the minimize the cost. You got to tell me the cost. If they want to find dimension, you got to minimize the dimension. Now, another thing that can be very, very useful in terms of commercial use. And that's why the commercial engineer is going to study a lot of that, try to optimize everything if you're an industrial engineer. So, so that you have to know some type of math, of course, to be in that kind of major. With that being said, so I'm gonna have to answer these questions. So I'm gonna annotate this. Okay, this is the first thing I want to optimize. The second thing I'm trying to optimize, I'm trying to annotate. Sorry. Huh? Yeah, sure. Give me a second though. Let me do everything for you first. With maximized volume. So I'm going to look at this question in particular. How do I solve these questions? So they say a manufacturer want to design an open box have a square base and it has surface area of 108 square inches. As shown in figure 3.53, I did not give you the box, it did not give you a figure. What dimension will produce a box with the maximized volume? So that you have to look at this question, you say, okay, what are we trying to maximize? Volume, good. So do we have a volume equation? Do we have a picture? Do we have assigned variables? So those are the questions you should ask yourself. Okay? So what I'm going to do is I'm going to do a box here. I'm going to draw a box. And with some type of assigned values here. And that box is like this. It was a horrible box, but anyway. So some type of box here.
So surface area as in on the outside or vertical? Because it's open.
What'd you say?
It says the surface area is 108 square inches. Is it just talking about the outside?
Yes. Let me share the screen. Okay, so first thing first, we're gonna look at this question, and we're gonna go back and look at all the things that we need to do. Is we're gonna look at all the steps. The steps there just kind of give you a general perspective. How would I do the problems? We try to optimize the problem. We try to optimize the situations. So what you suppose do? Okay, so we try to draw a picture. We draw a picture here. Have assigned variables. So how do we assign this variable? If I draw this box right here, how would I assign this variable?
Yeah, square. Oh, sure, yes.
What happened?
X. X for the side.
X for the side, okay. What else? X for the height, well, the height doesn't have to be the same. Because the question is mentioned square base.
What happened?
X for the width.
X for the width, how about the height? Oh, H, okay, good. So we got everything, square base. This one is gonna say H. And that's good. We have the first step done. We draw a picture, we assign a variable, everything's good to go. And let's go back to look at the questions. They say a manufacturer want to design an open box, have a square base, the surface area of 108 square inches. So how do we deal with 108? How do we manage the 108 situations? So 108 is called constraint because that's the material I have a constraint in. So how do I deal with the 108? Yes, Zach?
I would divide by 6 to figure out the area of like one of them, like the maximum area for one of them.
Okay, so first of all, there was an open top box.
Oh, it's
So it's not including the top.
That's a 5.
So it's 5. So it's a 5? I don't know. So that's the thing you have to pay attention to think about geometric shapes.
Yeah, alright, no, it's still 6.
Okay, it's more like.
No, actually, it would be 12. Oh, wait, no, 6.
Okay, Robert, what are you trying to say?
Like instead of being a rectangle and not being like a square, so you could like divide it by 5, saying all sides are gonna be equal.
So all sides are not equal. That's what you're trying to say,
Oh,
right?
you go on my way.
But there are a few sides are equal.
Yes, it'll be 4
There'll be 4 sides. So what are the 4 sides is?
XH.
XH, right? If you think about it, there's shapes, right? There's rectangular shapes that you're gonna have a 4. You're gonna have first. This is a base, and there is a 4 times of XH. Why? Because they are a rounding. It's called lateral face. A lateral face is in terms of water bottle. This is the lateral face. So if I ask you lateral face surface area, it's just the lateral. It's not including the top and bottom. So lateral has they are the different side because this one's gonna be 4 times. So 4 times this. Why? Because you got 4XH here. So those are the things that you should pay attention to. And you say, okay, I got this. I'm done. And then we're gonna go moving to the next subject is to build a constraint. So what will be the we're gonna build a primary equation. Sorry. So a primary equation here is gonna be V is equal to what? Volume is equal to what? Internal variable I assign, what am I gonna get?
X squared times H.
X squared times H, perfect. That's the value. But what is the surface area? Which is equal to 108, by the way.
It's like 4XH squared.
4XH
Plus X squared.
plus X squared, good.
Wait, isn't it like the inside of it though, too?
No, inside doesn't matter because inside doesn't matter.
Hey, there's a life lesson right there. What's it?
It's open top.
Yeah, it's open top box.
It's open dot box, yeah, it has no top.
Well, what's on the outside is everything.
So then you got a 2 equation set up. This is called a primary equation. So V equal to X squared times H. And the 108 is equal to 4xh because of 4 lateral side plus the 1 base. So base is going to be x squared. So that's 4 things plus the other thing. And then you say, well, what are we solving for? Are we solving for x or are we solving for h and y?
We're solving for both. Because it's asking for all the divisions.
Well, why do we need to solve something? According to the instruction, why do we need to solve something?
To find the maximum volume.
No.
I was like, take the root.
To what? Look at the third step. What are we trying to do with the constraint?
Oh.
Reduce variables.
Reduce the variable. Just like the one that we have a cone problem, we have a h in height, and we substitute, we solve for h and we plug it back in to take a derivative. It's same process, right? Same exact process as the cone problem. So if, that's why I assigned a cone problem, because cone problem has everything to do with here. Derek.
So is that the secondary equation?
That's a secondary equation. Yeah, 108 equal to 4xh plus x squared.
What's the primary equation?
What is the primary equation is the volume, because they're trying to maximize the volume. Volume equal to x squared h. So let me write down for you. This is the primary and this is secondary. On your test, if you write out this, I'll give you credit for half credit, not full credit. This is secondary. So you have primary and secondary, you are good. Now, if you use the secondary is to reduce the variables, how do you reduce it? Are you solving for, what are you solving for?
Reduce the variable h? No.
Why would you solve for h and not solve for x? H is right. Why would you solve for h and
You're
not?
trying to reduce the variable. You're not trying to like that's the base. It already has the base. You're just trying to.
Okay. But also the second reason, yes.
There's only one h, but there's multiple x's, and you don't want to go through all that.
Yeah. Well, yeah. And it's not possible to solve for x, by the way. Because you cannot get x by itself. Okay. I would really give a really bad analogy of this. It's like this. So it's like Derek decided to go in the club, and he see two lesbians sitting right there, and he see a girl sitting right there. And hopefully that he's smart. If you're gonna ask for phone number, he's gonna go ask for the single girl, but not the two lesbians.
Depends what time.
How do you know?
So I don't know. That was a very bad analogy. Hopefully I'm not offending anybody.
That was a beautiful analogy.
So
I don't get it. Can we continue?
you're not solving for an x squared. The x squared, get it? 2x, x and x. The
Yeah.
genetic component is x. So you cannot solve for that because you cannot break that apart. I don't know if that makes sense. So you can get an h apart. You can get h by itself. So then you can say 108
The guy or something?
equal to 108 minus x squared equal to 4xh. H equal to 108 minus x squared. And forgive me, this is a calculus class. I need to make it funny. Otherwise, this is pretty boring. So it wasn't meant to attack nobody. Don't cancel me.
Too late.
Too late. It's already been canceled on Twitter.
You already, check it.
Already trending on the Twitter. Cancel yeah, vote.
This is really.
That's free views.
Huh?
Free views.
Free views.
It is.
Revenue owns it.
So what happened is you have an x squared and you have a 108 minus x squared over 4x, and you can distribute that. You can cancel one of the x out nicely. So then you're gonna get 108
Wait, what?
over 4 times x minus extra third over 4.
So you plug that into the. Yes, that's right. That's part of the sentence.
Yep.
Blink my eye and this next thing's already done.
Yes.
Yeah, I have to, or else I don't understand.
And that's equal to 27x minus x3 over 4.
Said 27.
What happened is one of the x from numerator and one of the x in denominator, they can cancel. Once they cancel, then you can distribute the x. But the 4 on the bottom is one term, so you can split both terms. So that's you can simplify the 108 and 4. So that's going to give me this. Now this is the volume equation. This is the new volume that model this situation. This particular situation only fits the situation, this equation. Now what I'm going to do is I'm going to take a derivative of that. So I'm going to write down derivative of this. So write down v prime. So if I take a derivative of 27x, I'm going to get 27 minus the 3 is going to drop down. So it's going to 3 over 4x squared. And this, it just set it equal to 0 because we want to try and define the critical numbers, which is critical number could be maximum or minimum. So that's a very, very important. 27 equal to 3 over 4 x squared. And you're going to get 108 equal to 3x squared. X squared equal to 36. X equal to plus minus 6. Now, minus 6 is going to be filed against the physical domain. Physical domain is you cannot have a negative box. Although as much as you guys like to have a negative box, but it's just not going to happen. So x is always 6 in this case. So 6, you're going to plug it back in. So plugging back in where? Plug it back in all the way here. So it'll be 108 equal to 4 times 6 times h plus 36. So it'd be 72 equal to 24h. H is equal to 3. So I just find the dimension was 6 by 3. But here's my question. How do I know this is maximize and not minimize? Right? You could have minimize because you take a derivative set equal to 0. Could that be minimum? Possibly. How do we verify something? So here's how do we verify something. So we're going to verify this by, sorry, let me get rid of this. 6 by 6 by 3 is my answer. However, I want to verify by taking the second derivative. If I take a second derivative, 27 is going to become 0. And this one's going to be 3 times 2 over 4 times x. That's equal to negative 6 over 4 times x. And I'm going to plug in 6 in there. So it'll be negative 6 times 4 times 6. That's equal to negative number. If the negative number is concave up or concave down? Concave down, which is a maximum, right? Concave down, maximum. So therefore, is you just verify something with a second derivative test. Can I do the first derivative test? Of course. I just thought the second derivative test, it doesn't have to have too much math involved, and then I can actually simplify it much easier. Yes.
Why did you write 6 times 6 times 3?
What?
Oh,
Oh, because this is the base, right? This is the base is 6 that we got from 6 here. The square base, so 6 times 6, the height is going to be 3. Got it?
So what are we solving for?
We're solving for the dimension for the maximize the area volume. So here's my question for you guys. You guys finished copying?
Yes.
Hurry up. Then,
6 times 6
take a picture.
times 3, those are the dimensions.
Funny.
A mental picture.
I don't have photographs.
Goes like this.
So we were just.
Why don't you just look at that picture? That's one I think.
So would you have a solution for that?
Yeah.
Okay, cool.
Wait, what does that say? Negotiate?
Negative. Negative number. So it's concave down. So it's negative. My handwriting is so bad that nobody can read. Anybody want to say hi to Paige? Paige is on the Zoom.
Wait, are you doing the double derivative thing to check your answer?
Wait,
Yeah.
No, I think.
Are you doing the double derivative thing to check your answer?
Yeah. All right.
I have a question.
Hold on. Let me pose the questions first. So here's my question. And yes, you guys have homework. I know you guys really missed homework for the last 2 days.
No, we didn't miss that at all.
I actually had some time to actually think about it.
I've been able to
I actually
reconcile
had some
relations
free
with my
time
family,
finals
Mr. Ye.
yesterday. Actually, I probably need homework after that test.
So here's a question I want you to do. Suppose you have 102 meter of fencing. You want to build two side-by-side enclosure as shown. The picture already drawn to you. You don't have to do the hard part. What is the maximum area that you can enclose? Very interesting questions.
It seems like a question you would get in middle school or or like elementary school, but it's like way more complicated.
No.
You know, 102 meters of fencing to make two
Hey,
side by
Mr.
side.
Yang, about the last problem. So you know how we got x equals plus or minus 6? But then for when we plugged it into the secondary equation, why did we plug it in positive 6? What happened to the negative 6?
Because the sign
Negative
is
six.
negative.
Because you're gonna have a negative box,
Oh, yeah, I guess that's true.
an imaginary box.
I don't even know either.
Oh yeah, this is so.
You think so for the perimeter?
So the picture is already drawn to you. Assign some variable on it. You can use x and y. And you want to solve this problem? You got this. This is one of your homework questions. Come on.
Oh, it is. Sweet. Wait, how many homework questions do we have?
A few.
Oh, no. A few? A few? Two. Oh, so...
Well, I just copy it then.
Yeah.
So yeah, is it 3y plus 4x equals 102?
Are you sure to do this?
Sure.
I even read that problem.
Alright.
Oh, okay. I'm so stupid. Holy crap. I must be super.
Finally,
Yeah,
you're
like that.
trying to optimize. I think I did it.
Derek, get to the problem.
Find constraints.
He spelled my name wrong 3 times. He spelled my name. No, because you had it. You had that.
Wait, last name or first name?
My first name.
That's pretty sad. That's pretty sad. I can't even spell that right. And I'm not even like American. Now your last name is kind of hard.
V equals x
My last
squared.
Yeah, what's your last name?
Lopez.
Is it? Oh, I thought it was something else.
Wait, how do you spell
Are you
it?
stereotyping, Mr. Ye?
Huh?
Perimeter equation.
D-E-R-E-K?
Just add it.
You got it on the first try.
Just
My mom told me it was Lopez.
For all like the x.
Actually, part of my last name is Lopez, technically.
So I did.
I don't know how to spell Daniela. D-A-N-I-L-L-A?
D-A-N-I-E-L-A.
E-L-A? Daniela. Okay.
So 1L?
Yeah.
Primary, now you gotta find the secondary equation.
So Mr. Ye, can't you consider just as one line, like a top and bottom line? Don't put it on the line.
You can do that.
I can do that.
And then you're gonna get some answer. If you do, it's like 2x plus 3y. You can do that. Yeah.
Are we assuming that like the things that look similar are the same?
Yeah. It's usually the same in order to maximize.
Mr. Ye, does it even matter that it's two side-by-side enclosures?
It is matter, yes. Side by side.
Your weight convention.
So the secondary equation is like the one that equals 102.
You're just trying to find maximum area.
Yeah, and what's primary?
I don't know.
You gotta figure out.
It's right here.
I'm doing this.
Find what you're trying to optimize.
Yeah.
Optimize it.
What are you trying to maximize? Look at this question. Look at the question. What are you trying to maximize here?
The area.
Right, so can you give me an area equation in terms of this?
Oh, shoot.
Just
I'm so slow today.
2 times x times y.
Wait, what? How do you get that?
Ask Zach.
I'm so Did you talk about this yesterday?
We talked about different problem yesterday, but you were not here, but I recorded for you.
Okay.
Also page.
Is it like parentheses like x times y and then
And I tried to send you a Zoom link too.
I was.
See,
I didn't. No, I didn't. I didn't have my
I even
laptop.
texted you.
Should I put it in parentheses?
You
with
think
X
I
and
had
Y?
a question?
Huh?
Should I do like X and Y in parentheses and then 2 outside?
It doesn't matter.
Oh, it doesn't matter? Okay.
Wait, okay, I need some help.
Instructions say.
Let me get this and I'll double check it. I think I know what I mean, but at the same time, it's like,
I got area.
What are you trying to solve for? That's all. Insert the constraint into primary.
Oh, by minimizing perimeter. Oh, okay.
Constraint is primary.
You're not minimize the perimeter. You're trying to maximize the area. You already have a perimeter set. So you have a 102-meter fence.
I saw for what?
I think that's what you can do, right? Yeah, so you gotta solve for one of the values and then plug it in. Constraint into the perimeter.
Surface area?
Hey,
You don't need surface
Hey
area.
guys, plot twist.
You only need area, I'm pretty sure.
Plot twist, each fence post has an area of 0.7
Your
meters.
front area, yeah, this is primary. That's taken X times Y. Wait, why do you have 2? Oh, okay. And then this is equal to
Since we've agreed on the system.
answers. Now writing equation for that. How you use 100 meters of fencing.
Hey, you guys are pretty cool.
Yeah, X, Y, Y. It's fencing. And like you're using that fencing, right? So if you only have a certain amount, no, that should be Y. If you only have a certain amount of fencing, this will all count. This will take up fencing, this will take up fencing, this.
Okay, so since we only have 2 minutes left, I'm going to show you how do we approach this questions. So hopefully you have joined correctly. Now this is the work. No, not this one. Yep, this one. Okay, so you're trying to maximize the area. Area is equal to length times width. But in this case, they are 102-meter fence, so I'm gonna assign variable that way. So x, x, y, y, y. So what happened is, I'm gonna set equation of 102 is equal to 4x plus 3y. And then since the length is 2x times y, so it'll be 2x times y. Y is going to be 34 minus 4 over 3x. Once you solve for it, you're going to get 68x minus 8 over 3x squared. And then you're going to take a derivative, set it equal to 0. You're going to get 51 over 4, which is 12.75 meter. And then you're going to substitute back in to get y equal to 17. The maximum area is 2 times 12.75 times 17 equal to 433.5. Now, can you do the 2x plus 3y? You should get the same problem, except your primary equation is going to be x times y. That's only small difference. The answer should be exactly the same.
Thanks for
Yep.
another great Titan day.
Okay, this is not that bad.
You are now dismissed.
Now that I know that.
Condition for track. Aren't you
Paige, do you have any questions?
Aren't you guys
Let's keep this.
Yep.
Thank you.
Do you see what you did wrong?
Yeah, it's just some jump stuff.
So yeah, so
Yeah, so I think that A is fine. It just, I think there's something that it can be perfect, but it's okay.
so yeah, for y, I got 51 over 3.
Y I got 17. 51 over 3 is 17.
It's 17? I don't know.
Actually.
17 times 3 is 51.
I knew that. Just kidding. Of course I knew that.
I don't know. My 17.
Are you saying?
What I plug it into the primary or the secondary?
Huh?
Did I plug it into the secondary?
It's like a handshake equals type.
Oh, plug in to find the other link? Yeah, you have to plug in secondary to find the other link.
If I could try, look, not the same kind as you.
Does that say 51/4?
Yeah.
Oh, Frank! Hey, remember,
Alright, and then 51/4 is 12.7.